you ever wondered what it would be like to peek behind the curtain of reality? From quantum entanglement to the radical idea that information might be the core of everything, I'm going to share the incredible journey of understanding how our universe works and how it affects our intelligence and artificial intelligence. I'm Evan Goldstein. I'm a licensed professional engineer and a data scientist. I'm creating AI Capitalists to talk to the leaders and thinkers like you about how we navigate this new world of intelligent machines. So consider a dance between two particles that once touched and now remain apart forever, but are forever connected, no matter how far apart they may be. This phenomenon is known as quantum entanglement, and it challenges our most basic assumptions about reality. We find ourselves at a profound moment in human understanding, where the very nature of space, time, and reality is being questioned. What if I told you that the physical world we experience, the solid matter that we touch, and the space that we move through, the time that flows around us, might not be fundamental at all? That perhaps the deepest level of reality and everything that we know might be built from something far more abstract, pure information. Today, we embark on a journey to explore one of the most radical ideas in modern physics, the notion that information, not matter or energy, might be the fundamental building block of our universe. As we delve into this fascinating possibility, we'll discover how this concept could explain some of the most puzzling mysteries in quantum physics, and perhaps even reshape our understanding of reality and intelligence itself. Is information the ultimate reality? Research into quantum entanglement has revealed one of the most mysterious phenomena in physics. When two particles become entangled, meaning that they're created together or interact in certain ways, they remain fundamentally connected regardless of how apart they are. When you measure a property of one particle, like its spin direction, its entangled partner instantly exhibits a corresponding property, and this happens faster than light could travel between them, apparently. While our everyday experience shows us a world where space and time are distinct and where nothing can influence anything else faster than the speed of light, quantum entanglement seems to ignore these rules completely. Our brain's interface with reality presents us with a world where distance means separation and where cause and effect follow a strict order through time. But quantum entanglement suggests that reality's deepest level, what we might think of as reality's underlying programming code, these rules don't apply. Einstein, struggling with how this seemed to violate his theory of relativity, which states that nothing can travel faster than light, famously dubbed this phenomenon spooky action at a distance, in German Spukhaferverwinker. He found it deeply troubling that particles could seemingly influence each other instantaneously across any distance, as if the very concept of distance was meaningless at the quantum level. Exciting new theories like quantum gravity suggest that space-time might actually come from something deeper than we just can't perceive yet. This idea hints at a potential explanation for the puzzling connections that we see in quantum entanglement. A pioneering thinker in this arena was John Archibald Wheeler, an American theoretical physicist who made significant strides in both nuclear physics and Einstein's gravity theory throughout the 20th century. Wheeler, who famously coined terms like black hole and wormhole and worked closely with Einstein, proposed a pretty radical perspective on reality. He suggested that what we consider to be physical things like particles, energy, and even space and time might not be the basic building blocks of the universe at all. In fact, he had his brilliant idea encapsulated in the phrase, "it from bit," suggesting that everything we know, every particle, every force field, and every aspect of our universe comes from bits, the yes or no answers to questions that we pose through our measurements and our observations. For instance, when we detect an electron, we're really just getting answers to whether the detector clicked or not. This notion paints reality as a vast computer program where our physical surroundings are generated from an underlying world of pure information, similar to how 3D graphics in video games are crafted from computer code, even though they appear to reflect 3D objects like the world around us. This perspective has profound implications for both artificial intelligence and modern capitalism. If reality itself is fundamentally information-based, then AI systems which process pure information might be better equipped than human minds to understand and manipulate these deep structures of reality. Similarly, just as modern financial markets have evolved from physical exchanges to digital information flows, perhaps our entire understanding of economic value needs to shift from material assets to information-based ones. The success of companies like Google and Amazon, which built trillion-dollar empires primarily on information processing, might be early indicators of this fundamental shift in how reality operates at both the quantum and at economic scales. This groundbreaking thought suggested that information, rather than matter or energy, could be the core building block of everything around us. And it also hints that the act of conscious observation plays a significant role, which it implies that consciousness might actually be a fundamental part of reality itself. So while our experience of reality stays pretty constant, its ultimate nature may be more like a projection or a hologram, and that reshapes our understanding of reality altogether. What's exciting is that our perception of reality remains stable, and it seems very likely that the fundamental nature of reality is constant too. What changes are the tools that we use to explore it. Thanks to rapid technological advances, we're uncovering the vast differences between what's real and what our brains perceive as space-time. This exciting journey isn't anything new. Past innovations like the microscope and the telescope opened our eyes to realms beyond our natural senses, expanding our understanding of the world. Now, with the high-performance computers, AI, and big data, we have sharper tools than ever to peel back the layers of reality. These advancements are creating a dynamic loop where the same technologies that enhance our observations are also driving their own evolution. For example, think of AI helping someone develop ultra-precise sensors. This interconnected cycle amplifies our ability to dive deeper into the nature of reality. This convergence of AI and physics research mirrors a fascinating pattern in modern capitalism, the way that technological advancement creates positive feedback loops of information and value creation. So just as companies like NVIDIA build better AI chips that help design even better AI chips, our AI tools are studying quantum phenomena, and they're becoming sophisticated enough to suggest new experiments and theories, which in turn lead to better AI tools. And if you're enjoying this content, I would appreciate it if you would hit the like button. Hitting like lets me know that I'm making content you want to see, and it spreads that content to others. Let's work together and break AI capitalists out of small channel hell. Thank you. Now, this virtual cycle of advancement, familiar to both scientists and entrepreneurs, might be our best path toward understanding reality's deepest nature. In a nutshell, we're understanding our universe, matter, and the essence of reality at breakneck speed. And along the way, we're increasingly recognizing the gap between our perception and reality's true essence, while also discovering that reality itself could just be a projection of something even deeper. An enigma. Now, when we dive into the true nature of reality, it's hard not to think about Plato's allegory of the cave. In Book 7 of De Republica, Plato, the Greek philosopher Plato, paints a picture of people shackled in a cave, watching only shadows of the outside world dancing on a wall, and all the while believing that those shadows are the entirety of existence. To me, this allegory feels a bit abstract, because even in such a scenario, they would still experience their own bodies and their position of three-dimensional space relative to the shadows, rather than a flat two-dimensional realm. So it makes me wonder if Plato is trying to describe the nature of reality itself. But we'll suspend any doubts for now, but I see this allegory as a way to demonstrate that we only perceive what our senses provide. From that limited input, our brains create a model of reality, like a virtual interface. We end up feeling stuck in a perception that our brains have pieced together, missing out on the deeper truth of reality. Imagine that you're familiar with a city, and you can easily find your way around its streets and squares. But when you catch a glimpse of the city from a nearby mountain, new features that you hadn't noticed before suddenly pop into view. Your understanding of the city and its layout changes and improves. When you're back down in the streets, you'll have a refreshed feeling for your surroundings. In my opinion, Plato's intention was to highlight how we often confuse our limited perceptions for the full truth. Just as advancements in physics have deepened our understanding of reality, we're gradually unraveling the mysteries of how our brains perceive things too, even if it's at a slower pace. So how do modern scientists understand our perceptual limits? Psychologists and neuroscientists are exploring the amazing workings of our brain, and they're diving into how our perceptions come to life and contribute to our consciousness. One interesting perspective comes from cognitive psychologist Donald Hoffman, who suggests that our perception actually filters out certain aspects of reality, zeroing in on what keeps us safe and sound. If we didn't have this built-in filter, we could become overwhelmed with too much information, making it hard for us to navigate the world. It seems that evolution has fine-tuned our perception to prioritize survival over a complete understanding of reality. If a species were to see everything in all its complexity, they might end up wasting precious energy and resources, which would make them an easy target for other creatures better equipped for survival. This theory about how our brain creates a simplified interface of reality, similar to how a computer creates a user-friendly desktop that hides the complex operations underneath, fits remarkably well with quantum mechanics' discovery about observation in reality. When quantum mechanics shows us that the act of measuring or observing something actually helps to determine its final state, and Hoffman's interface theory suggests that our brains deliberately show us only a limited survival-oriented version of reality rather than its full complexity, these ideas support each other in a fascinating way. Just as quantum mechanics tells us that reality isn't fixed until it's observed, the inference theory suggests that our brains actively participate in constructing our experience of reality by filtering and simplifying the vast amount of information that's around us into something that we can manage. Both concepts point to the same conclusion. What we think of as solid, objective reality is actually more like a collaborative creation between the observer and the observed, with our conscious perception playing a crucial role in shaping what we experience as real. Anil Seth, a leading neuroscientist and a professor at the University of Sussex, who specializes in consciousness research, offers a fascinating perspective on how our brain creates our experience of reality. He argues that what we think of as perception isn't just our brain passively receiving and processing information from our senses. Instead, he describes perception as an active process. Essentially, it's a carefully controlled hallucination that our brain creates based on two streams of information. The first stream flows bottom up, carrying raw sensory data from our eyes, ears, and other senses into our brain. The second stream flows top down, carrying our brain's predictions and expectations about what we should be experiencing based on our past experiences and learned patterns. And these two streams meet and interact continuously, with our brain constantly comparing its predictions against incoming sensory information. And it updates both to create our final perception of reality. Seth uses the term controlled hallucination because our experience of reality is actively constructed by our brain rather than passively received. It's like our brain is constantly making its best guess about what's out there in the world, and then showing us that guess rather than showing us raw reality. And this process helps explain why optical illusions work, why we can see faces in clouds, and why different people can perceive the same situation in radically different ways. Immanuel Kant, a revolutionary German philosopher who lived from 1724 to 1804 and spent most of his life in Königsberg, Prussia, introduced a profound idea that transformed how we think about human perception and reality. In his landmark work, Critique of Pure Reason, Kant proposed that there's a fundamental difference between what he called das Ding an sich, the thing in itself, the actual objective reality of something, and what we perceive that thing to be. Kant argued that whenever we experience anything in the world, we can never know its true, fundamental nature because our minds automatically process and organize all of the incoming information through built-in mental frameworks, particularly through what he called the intuitions of space and time, and certain fundamental concepts like causality. It's as if our minds wear permanent glasses that color and shape everything that we see, and we can never take these glasses off to see reality as it truly is. For example, when you look at a tree, you're not seeing the tree as it truly exists in objective reality. You're seeing it as your mind has processed and organized it through your human sensory systems and through mental frameworks. This revolutionary idea suggested that human beings are forever separated from knowing the true nature of reality by the very structure of our minds and sensory systems, a concept which remarkably foreshadowed modern neuroscience's discoveries about how our brains process and filter information. This aligns well not only with my interpretation of Plato's allegory, but also with the latest findings in neuroscience. Ultimately, perception is the virtual reality of all living things. So is the transition from perception to consciousness just another mystic quantum effect? We have to first ask what consciousness really is, how it comes together, and how it connects to our virtual reality. Alongside self-awareness, our subjective experiences, like the vibrant redness of red, the delightful taste of chocolate, or the sweet scent of a rose, are integral to what it means to be human. The modern Australian philosopher David Chalmers famously dubbed the intriguing mystery surrounding the relationship between physical workings of our brains and our personal conscious experiences the hard problem of consciousness. If you're interested, you can check out this episode for a deeper exploration of this captivating topic. While there are many approaches to solve this riddle, one curiously links back to quantum mechanics. Sir Roger Penrose, who's a renowned British mathematical physicist who won the Nobel Prize in Physics in 2020 for his work on black holes, developed a fascinating theory about consciousness after studying both mathematics and quantum physics during his time at Cambridge. In his view, consciousness isn't just a product of a simple brain chemistry, but it emerges from quantum processes occurring within brain cells. Here's what makes this theory so interesting. Penrose suggests that consciousness and quantum mechanics are connected in an unexpected way. Instead of consciousness simply observing quantum events like many early quantum physicists believed, Penrose proposes that consciousness itself arises from the quantum processes in the brain, and these same processes then influence how quantum events unfold in the world around us. To understand this, let's imagine that quantum particles exist in multiple possible states at once. Like a coin, you flip a coin spinning in the air is neither heads nor tails until it lands. When we observe these particles, they collapse into one definite state, like the coin landing on heads. Penrose suggests that this collapse isn't caused by conscious observation, but rather that consciousness itself emerges from a kind of quantum collapse happening in our brains. As he explains in the interview, he and his colleague Stuart Hammerhoff identified structures called microtubules within the brain cells as possible sites where these quantum processes might occur. What makes this theory particularly interesting and intriguing is that it suggests that our consciousness isn't just passively watching the world, but is itself a quantum phenomenon deeply connected to the fundamental nature of reality. It's as if consciousness and the physical world are effortlessly dancing together, each gently influencing and shaping the other, with neither truly separate or independent. So this concept hints that our minds and the matter around us might be intertwined at the very core of reality, as opposed to being distinct entities that just happen to interact. In simpler terms, consciousness doesn't merely watch the universe unfold. Instead, it plays an active role in shaping its state. This perspective suggests that our minds aren't just the result of reality, but are a vital piece of the structure. This idea resonates with the beliefs found in various Eastern philosophies and religions, which have embraced this understanding for centuries. So as we draw this chapter to a close, we find ourselves facing a profound possibility that beneath the familiar fabric of space and time lies a deeper reality, composed not of physical things, but of pure information. And this insight, first glimpsed by visionaries like John Wheeler, suggests that what we call reality might be more like a vast tapestry of interconnected information weaving together to create the world that we experience. The implications are humbling and exhilarating. They're humbling because we realize that our everyday experience of reality might just be the surface of a far deeper truth. And it's exhilarating because with the new tools like artificial intelligence and quantum computing, we stand at the threshold of penetrating these deeper layers of reality. In episode 2, the series is going to go deeper into how our observations might actually shape reality, exploring the mysterious relationship between consciousness and quantum mechanics.